Okay, folks, in this video lesson, we're looking at working with surds, specifically rationalizing the denominator, okay, in this first part, and solving an equation involving rationalization. Okay, so we're rationalizing the denominators, okay, so quite an important topic for AS pure maths. Express 1 plus 4 root 7 all over 5 plus 2 root 7 in the form m plus n root 7, where m and n are integers. So we're going to rationalize, okay, our denominator. So we're going to multiply top and bottom of this fraction by 1. But I'm going to rewrite one here in a very specific case, and you'll see why in a second. Okay, so we're going to multiply top and bottom by the conjugate of the number of numbers here on the bottom of the fraction. That just means that I'm going to flip the sign in the middle. Okay, so I'm going to times top and bottom by 5 minus root 7 over 5 minus root 7. Okay, you'll see why I'm doing it in just a second, actually, or just a moment. Okay, so multiplying fractions, I multiply top by top, bottom by bottom. So 1 times 5 is 5. 1 times minus 2 root 7 is minus 2 lots of root 7, or minus 2 root 7. Plus 4 root 7 times 5 makes positive or plus 20 root 7. And then plus 4 root 7 times minus 2 root 7 is minus 8 root 49, because root 7 times root 7 is root 49, okay, which is just 7. So I have 8 times 7 at the top, okay. And on the bottom, guys, we have 5 times 5 is 25. 5 times minus 2 root 7 is minus 10 root 7. Plus 2 root 7 times positive 5 makes plus 10 root 7. And plus 2 root 7 times minus 2 root 7 is minus 4 times 7. So that ought to be minus 28, okay? Because 2 times minus 2 is minus 4. Then I've got root 7 times root 7, which is root 49, which simplifies just to 7. Remember your laws of surds. If I have root b times root b, that is just simply b, okay? It's just simply the number inside, okay, the square root or the root, okay? So root b times root b is just b, okay? Root 5 times root 5 is 5. Root 6 times root 6 is 6, so on and so forth, okay? So therefore root 7 times root 7, if you're ever unsure, is root 49, which simplifies to 7. Okay, so now from that part here, I'm now going to tidy up the numerator and denominator. So we got 5 minus 56 here, so 8 times 7 makes 56. So we got 5 minus 56 here for our numbers. Then we got minus 2 root 7 plus 20 root 7 is plus 18 lots of root 7. And on the bottom, guys, what we're going to have, well, these are going to cancel, so that's going to go to 0. 25 minus 28 is minus 3. Okay, tidying this up, guys. 5 minus 56, guys, is minus 51. Think of it as 56 here minus 5, which is 51, and then you put a minus sign here at the front, or you stick a minus sign at the front. Then I've got 18 root 7 all over minus 3. So dividing everything through by minus 3 or negative 3, we're going to get 51 over 3 makes 17. Then we're going to get 18 over minus 3 is going to be minus 6. And we're going to attach the root 7. So essentially m is equal to 17 and n is equal to minus 6. Okay, that's the first part done, okay, for 4 marks. Okay, next up, solve the equation x brackets 9 root 5 minus 2 root 45 equals root 80, giving your answer in simplest form. Now the first step here, before I rearrange it, I'm going to simplify root 45 first and root 80 first, and then do my division. Okay, so I'm going to copy down, okay, the x brackets 9 root 5 minus, and then I'll put 2 there. So root 45, I can simplify here this surd. So looking for the biggest square number factor, that'll be root 9 times root 5, or the square root of 9 here times square root of 5. Okay, root 9 here, the square root of 9 is just 3, so we have 3 times root 5, which is 3 root 5. Obviously putting that 2 at the front there, so we're going to have minus 2 lots of 3 root 5. And on the right hand side equals root 80 root 16 multiplied by root 5. Okay, so root 16 is going to be 4. 4 times root 5 is 4 lots of root 5. Okay, I'm now going to tidy up, okay, the left-hand side, so collect my like terms. So 2 times 3 is 6. So we have 9 root 5 minus 6 root 5 makes 3 root 5, okay? So that is going to now become x lots of 3 root 5, okay, is equal to 4 root 5. I'm now going to divide both sides of my equation by 3 root 5, okay. They're going to cancel, okay, that's what's going to cancel on the right hand side, leaving us with just x is equal to 4 over 3, or 4/3, as my answer. So can you see here, guys, that by simplifying it first, okay, we actually avoided the step of rationalizing, okay? I mean, we could have actually rationalized it and that also works, but I thought to simplify root 45 and root 80, okay, as something times root 5, okay, and then something else here times root 5, and then collecting like terms here. So just to be clear here, the 3 root 5 here came from, so we got to this stage, right? So we got to 9 root 5. Then I had minus 2 lots of all this. So I had minus 2 times 3 is 6. So I had minus 6 root 5 there. And then root 80 was equal to 4 root 5. Okay. I then collected like terms. I got x lots of 3 root 5, or 3 root 5, yeah, lots of x is equal to 4 root 5. Then divided both sides of my equation by 4 root 5. Okay, so I simplified root 45 first, then I simplified, yeah, root 80. Okay, looking for the biggest square number factor. So I'm factorizing, okay, I'm factorizing these numbers, okay, pulling out the biggest square number factor. Remember, if you're unsure, your square numbers here are going to be 1, 4, 9, 16, 25, 36, okay, 49, 64, okay, 81, and 100. Okay, again, I'm not going any further, okay, because we probably don't need that many. Okay, we obviously disregard actually 1 in this case, because 1 times anything is itself, but they are your first non-1 or non-ones square numbers. Okay, what number goes into, okay, 45 and 80? Well, 5 goes in both, okay, and the other number will be, yeah, a square factor, okay, or a square number, okay. So revise here your square numbers, but yeah, if in doubt, okay, write out your square numbers, yeah, okay, if you're unsure. But that is how we simplify or manipulate here or work with surds, and that is how we rationalize our denominator in the first question, okay. Hope that makes sense.